Hello, algebra students. In this video, we're going to move on to section 11.3, which is solving radical equations. So in our last section, we simplified radical expressions. So radical expression just meant that there was a radical symbol in the expression. That's pretty much what a radical equation is. It's an equation containing a radical expression with a variable in the radicand. So it has a radical symbol and there's a variable underneath the radical symbol in the radicand. The way that we solve these is pretty much the same exact way that we did back in chapter 10 when we had equations like this. So if we had x squared minus 25 equals 0, our goal was to isolate the term being squared and then take the square root. Sometimes we would have something like this, and we'd have to isolate this entire expression right here, this grouping, this set of parentheses, because that's what was being squared. In both of those, once we did our inverse operations to get that thing being squared by itself, then we took the square root of both sides. We're really doing the exact same thing, except we're flipping it around now, because now we have a square root in the equation, so the inverse of that would be to square both sides. So I want you to take a minute, pause the video, copy these steps, and then unpause the video and I'll talk through them. So hopefully you copied these steps in your notebook. This is how you're going to solve radical equations. First thing you're going to do, isolate the radical on one side of the equation. So just like we did in chapter 10 with the squared term, the x squared or the set of parentheses squared, get the radical symbol and whatever's under it by itself. Second, you're going to square both sides because that's the inverse of the square root. After you square both sides, then just solve for the variable, get the variable by itself, and check step 4. You always have to check your solutions. The reason that you have to check your solutions every single time is that because we square both sides in step 2, sometimes it's called an extraneous solution. And it's a solution of the equation after we square both sides, but it's actually not a solution to the original equation. So in step 4, when I say check solutions, this is with the original equation. Make sure that you substitute your solution or solutions into the original equation and make sure that they work. Let's look at some examples. So first, the radical is right here. All it has is the x underneath it. So we need to isolate that. To do that, we would add 8 to both sides. We'd get 2 times radical x equals 8. This is multiplication, so we would divide, that's the inverse, and we would get square root of x equals 4. And now is where we would square both sides. We're taking this radical x and we're squaring it, and we're squaring the 4. Whatever we do to one side, we have to do to the other. So square root of x squared, those are inverses. That radical, that square root, and this exponent of 2 just undo each other. So this just gives us x. 4 squared is 16. So x equals 16, but we need to check it. So this is the check. Go back into the original. 2 radical x minus 8 equals 0. Substitute 16. And check. Radical 16 is 4, so this is 2 times 4 minus 8 equals 0. That's 8. 8 minus 8 is 0. We get the same thing on both sides. It satisfies the equation. So x equals 16 is our solution. Here's another one. Isolate the radical. So 3x is under the radical this time. We're going to isolate it. Subtract 9. So radical 3x equals negative 9. And then here's where we're going to square because the radical is by itself. So square both sides. We're squaring the negative 9. Again, this radical, exponent of 2, undo each other. That just equals 3x, whatever's under the radical. Negative 9 squared. Negative 9 times negative 9 is 81. Divide by 3. x is going to equal 27. So let's double check. So let's check our solution. Back in the original, radical 3x plus 9 equals 0. So this is 3 times 27, all under the radical, plus 9 equals 0. 3 times 27 is 81. Square root of 81 is 9. 9 plus 9 is 18. 18 does not equal 0. Here's an example of an extraneous solution. So this is not a solution to the original. So there are no real solutions, because the only solution we got was actually an extraneous solution. So no solutions for this one, no real solutions. Real meaning real number. Let's do one more. So in this one, isolate the radical. So 3 times radical x equals 6. Divide both sides by 3. Radical x equals 2. We have the radical by itself. So let's square both sides. Radical x squared is just x. 2 squared is 4. X equals 4. Let's check. Make sure it's not extraneous. So copy my original equation. 3 times radical 4 minus 6 equals 0. So radical 4 is 2. So this is 3 times 2 minus 6 equals 0. 3 times 2 is 6. And 6 minus 6 is 0. Satisfies the equation. Our solution is x equals 4. So that is a video introducing how to solve radical equations. We will build on this as we continue moving forward, but I think that will help you start solving radical equations. Have a great day, guys.